Hi friends, my name is Akshay Kumar. Today in this video I am going to explain about the topic reduce operations on sequence and aggregate values. First, let us see what is reduced operations. They allow for the transformation of a collection of values into a single aggregated result. That means suppose if we have a large amount of data, it is difficulty to manage it. So that's why we'll transform this large data into a single aggregated result. Reduce operations are critical for processing sequence of data, and understanding these operations is essential for efficient data manipulation in program. Now let us see what are sequences. By the term sequence, we can understand that sequence or order the collection of elements that can be processed in various ways. There are some common sequence types include list, arrays, and strings in programming. Applications. Sequence are fundamental in programming used for storing and processing the data efficiently. There are some operations on sequences like mapping, filtering, and reducing because reduced operations on sequence is the center topic of functional programming. Mapping applies a function to each element, create a new sequence. Filtering selects elements based on a condition, producing a subset. Reducing combines elements to produce a single result, often used for aggregation. To understand these mapping, filtering, reducing operations in clearly, let us see an example. Let us see this example. This is the This is the input statement. Now let us divide this input statement into subsets. These three are subsets. Now again we divide these subsets further so that each each subsets of elements will be shown here. This is called mapping. And next we will separate all the elements. This is called filtering. Of Now let us see here beer 1 and beer 1 are there for two times. So these can be written as beer 2. This is called reducing. And the collection of these reducing sets is will be the final result. Now let us see the importance of aggregating values. Some of them were data summarization and decision making and efficiency. Now let us see data summarization. Aggregation condenses large data sets into meaningful summaries. It reveals patterns and trends. Decision making. Aggregated data supports informed decision making. It provides clear metrics for analysis and efficiency. Aggregating reduced data volume. This improves storage and processing efficiency in systems because if we have large data sets, we are dividing them into small sets. So it can be useful for it. So it is useful for storage and processing the system. There are some commonly used aggregate functions like sum, count, average, and min-max. Now let us see about these in detail. Aggregating with sum. Sum adds all elements in a sequence. It's useful for financial calculation. That's we all know. Now let us see the implementation. We all know in most of languages, sum is a built-in function. It handles numeric sequence efficiently. Now let us see the considerations. We continue with floating point numbers. Rounding errors can accumulate in large sums. Now let us see the aggregating with count. The the aggregating with count is nothing but it will calculate the total number of elements in the set. So the algorithm involved in this count is first initialize. Let us start with a counter and set the value to 0. Now then we iterate, go through each element in the sequence. Now we increment and one of the counter of each element. And at last result, the final counter value is the count. Now let us see aggregating with min and max. Function min is useful to find smallest value in the given set. Use case of this min is identifying lowest score. Now let us see max function. This is useful for finding largest value. One of the use case of max function is determining highest temperature. Now let us see the function both. This is useful for finding the range of values. The one of the use case of both function is analyze data distribution. Now let us see the aggregating with average. That means mean. First we should find the sum value. That means we should add up all the elements in the sequence that are given. And then count we should count elements. That means determine the total number of elements in the sequence. And then we divide. That means divide the sum by the count to get the average. Now let us see the performance consideration. Reduced operations can significantly improve performance by simplifying complex calculations because we are reducing from larger set to smaller set. It is essential for the computer. They minimize the need for explicit loop, leading to more concise and readable code. However, care must be taken with large datasets to avoid performance bottleneck. Parallel reduce operations. Parallel reduce techniques can significantly speed up computation because if you see this example, we are reducing the operations simultaneously. This approach divides the sequence into smaller chunks produced simultaneously. It is useful in big data application to handle large volume of information. This approach can drastically reduce computational time for large dataset. You can understand better by seeing this example. Use cases in data analysis. Reduced operations are widely used in data analysis for generating summary statistics because reduced operations will reduce the larger data into the smaller data, which is which is useful for us. They help in transforming raw data into meaningful instance quickly by using these parallel reduce operations. Many data processing frameworks like Apache Spark utilize reduced functions for efficiency. Now let us see how grouping data is useful for aggregation. Grouping organized data into categories before aggregation, it enables more detailed analysis. Applications. Grouped aggregations reveals patterns within categories. They are crucial for complex data analysis. I hope this video is useful for you. Thank you.